Perfect. Yeah, I can hear you clearly. Great.
Okay, good. Yeah, I don't have a too formal presentation, so if you have any questions or ideas, just interrupt me at any time. So I don't want to talk for an hour, but have a conversation with you. What I'd like to show you today is yes, semantic text, improving exploratory programming in Squeak with generative AI. And yes, we have been working on this for, I think, about one and a half year. And we built some different things. We tried to first integrate large language model into Squeak in general, and provide some frameworks and tools for it. We also integrated them into different existing tools in Squeak just to try out some ideas how we can benefit from AI and usual working flows. And later I will also show you some of our latest features on how we can actually talk to objects in natural language from the runtime system. And if then there is even more time, then I also have a new very new prototype for you. We will see whether the time is enough for that. I've prepared some very only 3 slides, and we are done with the theory. So just as a short recap, I don't know who of you already knows what large language models are and how they work. So you could raise your hands if you'd like to.
Yeah, cover off some introductory stuff as well. I think it's always nice to get everyone up to the same level.
So just briefly, so the one thing is actually something which most people will have used generative AI models. So the large language model completes some text. Conversational agents like ChatGPT do the same, just that they have some conversational structure. So we have messages on behalf of a virtual assistant that are generated. And autonomous agents have some other features. They also generate function calls, which are then resolved by the system, and later the responses from the system are fed back into the context of the large language model, which allows the model just to interact with its environment and use external knowledge sources, use external algorithms and other things. And the other thing are text embedding models, which you already also maybe have used today for any kind of recommender algorithms. So if they are like getting some recommendations about movies on Netflix, or if they are doing a Google search, then embedding models are involved. Essentially, an embedding model takes a large document or a text and translates it into a high-dimensional vector of numbers, which we call an embedding. And the idea is that these vectors represent the semantics, so the features, the inner meaning of these documents, and we can compare these vectors to understand how similar some objects are. And you can also visualize it, and you end up with a large space with many dimensions. And essentially, if you would, for instance, have 3 vectors for 3 documents in Squeak, Pharo, and Python, then you would probably see that Squeak and Pharo have embeddings that are much more closer to each other, so the distance in the space is smaller, and we can use this for different operations, such as recommending similar documents in a system, or grouping things, or searching them based on other objects. And so these are some foundational capabilities that language models offered. And in semantic text, we try to integrate them into Squeak. And coming back to the name, the idea is actually that we take a semantic look, a look at the actual meaning of text and other objects, and integrate this logic not only as a framework in Squeak, but also as a part of the standard tools and part of the different, even part of the language, actually. So I can just move for the architecture here, what I'd like to show you today. So semantic text and what we have built with it can be described as these different layers here. So we have, at the beginning, we have at the bottom different model providers. We have an OpenAI client for the models from the OpenAI API, such as GPT-4, and some embedding models and some other models. We have some other providers, such as for mocking or for some other models, which we also use for accessing speech. Then we have domain models, so we can model conversations, semantic search, agents and also voice automation that's in Squeak. And based on top of that, I will show you different tools that we have built with this framework and some integrations into base systems of tools. Yes, and now we can actually start with the demo. So the very first thing that I will do is that we have this ChatGPT window here, and this works just like a regular chat windows, like ChatGPT. So we could ask something like, what is Squeak, and get back an answer. So, okay, it's acknowledge that there are different definitions of Squeak. I can also edit this again and ask what is Squeak Smalltalk, and hopefully get a more precise answer. Okay, that looks good. And next to the normal text model, we also have some voice models here. I just hope that they also work when I have Zoom enabled. I have not tried it before. Write a very short poem about this in 4 lines. Okay, so apparently Zoom blocks the microphone, but in theory, you can also have voice conversations with the models with this. And yeah, this is just the UI that we have built for this. So you can see the user assistant message here. You can even also edit the assistant messages if that makes any sense. So you could just predict the tone and that the assistant answers. So if I would only answer in one system, in one sentence, Squeak Smalltalk is an interactive programming system, then the next answer might be in a similar style. Let's see whether this works. Well, not really, because the models are more trained on following instructions, but you can actually edit at each part of the conversation to get some impression of what you can do with the models. And this is only the first part, and you already can see that this also costs money. So the API is not free to use, which is why you can also see this expense tracker here. So we can also track the expenses of all the API models here, and just see how much we have spent for each model. And you can also see the context size that we have available, because you can actually only provide a limited amount of text into the model. And so we can also see some information here, such as that the longest possible answer which I might get from the model at this point would cost me only 4 cents. So 1 year ago, this would have been several dollars, but just today the prices have decreased a lot. So it's not free, but if you only use something like $1, you can probably try out a large number of experiments already. Okay, so now we can make it a bit more interactive. And what we also can do with this interface, besides only using ChatGPT, is that we also can use this for prototyping and debugging our own agents. And for this, I can start again, and here at the bottom we have this advanced mode, and when we press it, then we can actually edit all the, let's say, meta information that belong to the conversation. So instead of only user and assistant messages, we can also add system messages that describe what the agent should do. So for instance, I could say only answer every question in 1 sentence, and when I then ask my question again, what is Squeak Smalltalk, then I get back a much shorter answer. But what actually makes an agent interesting is that we can also define our tools here. And here I can press on Add Tool Spec, and in this moment we just create some specification with tools here with one predefined eval function that can evaluate a mathematical expression. And then I can ask something like, what is 2 plus 3? And then we can see that the assistant first creates a function call to call this function. Second, this function, this tool returns a value, and third, the assistant uses this result and provides an answer to us. And so this is a very first agent that we have got. And now we can also prototype our own agents here. So for instance, we could now try to build a small agent that allows us to just to understand how classes in the Squeak system work. And so I can define a function that allows our agent to access the comments of any classes in the system. And so I can, okay, let me start again. I can now add the tool spec here and define a, get class comment method here and provide a name argument, which should be a string. And for now, I have not implemented this function. I have just declared it. And now I can already start to prototype our agent with this function to see how well it is able to understand how to use the function, and ask something like, what does the class semantic streaming methods do? And then we can see that the assistant tries to call this function, but because it is not yet implemented, the call is not resolved, but we can mock the result by adding a tool result manually to the conversation, because we actually can see and edit all the different parts of the conversation here before it is sent to the language model again. And so now I can just prototype the behavior of this by opening this class manually, copying over the class comment, inserting it here, and then completing this, and then the assistant is able to see the result of the function and provide an answer based on that. And if I'm happy with that, then I can continue to actually implement this method. So I can click on this action and provide, and this function and provide an action here, which would be something like a block that takes all the arguments, takes the name, and then says Smalltalk class named args name, and then we want to get the comment from that. And then we can try the same again. And now you can see that it also works automatically. Okay. Whenever you have a question or an idea, just let me know. Otherwise, I will continue.
Christoph, Elliot here. If you wanted to quibble with it when it said our programming system derived from Smalltalk, and you wanted to tell it that it was built in Smalltalk, how would you go about doing that?
Not yet sure what you mean by that. Could you explain this first?
You asked it the question when you told it to answer in one sentence, and it provided you with a sentence, and one might want to quibble. I'm not interested in the quibble. I'm interested in can you in this invocation teach it things. So, for example, if you were to try and teach it that instead of a Squeak being derived from Smalltalk, it was built in Smalltalk, or if you wanted to ask it, what does it understand by derived from as opposed to built in? Is that a meaningful conversation that you can have with it? And by the way, I'm really very keen to see more cats embedded in Smalltalk development. I have my cat on my bed in my backpack right now, and your cat looks beautiful on the radiator. So
okay, well, this is as powerful as a regular ChatGPT is, so you can teach it about anything. You can, yes. So I'm still not actually sure what concretely you would try to achieve, but I would be able to now explain it that it is sitting in a Smalltalk image, and we can also teach it to use the different classes in the system, which I will show later. Yes, so maybe I will come back later to this question again, if that's okay.
Can you hear me?
Yep.
Yeah, Elliot, there are two ways to do that. You can issue further user prompts that correct anything that the model said before, and you can also sort of pre-hallucinate answers. You can lie about what has happened in the conversation so far, because the model is stateless. Every request you make repeats the entire conversation, and you can change what already happened in the conversation if you want.
Yeah, exactly. It's all stateless. And whenever I added something in the conversation earlier, then I essentially send everything again to the model, and it will process it again. Okay. What else can I show to you? I have a lot of things prepared. Yes, exactly. So now we can also make real code from this. So it's just a small feature, but when we are happy with how the agent works, then we can delete what we have, how we have used it, and just generate code from it. And then we also have executable code that we can use to just to use this and to embed this in other parts of the system. Unless something goes wrong. What is that? Okay, because we have an invalid message here. So I could ask it about another class. What does collection class do? And then we also get back some result. We can also edit several hyperparameters of the large language model. So one popular example of this is a temperature. And I could set the temperature to a higher value here. The temperature is used for just describing the randomness or also the creativity of the model. And by using a higher value for it, we just might get more creative answers. And if I try to run the function, then we already get some error because the randomness is so high that it is not even able to run the code to use the functions anymore. And in this example, you can see that we have, instead of collection, we have called this function with some random string essentially, because if we set the random very high, this does not only lead to creativity but also to the model creating nonsense. So I can also demonstrate this to you by asking just another question: what is a computer? And then you can see that it starts to output nonsense at some point of time because the temperature is set too high. But in other situations, you can tune this parameter just to create a bit more creativity in the results, or on the other hand, to lead to more stable results. Okay, that's enough for now.
That's hilarious.
Yeah. And we can also do some other interesting things by setting some of the configuration things. Some example is that we can, where did I put this? Another utility that I built is that we can have something like the apple, banana, cherry, and then complete this with the next 5 elements. And okay, then we get back some other things in the implementation for that. Basically, this puts the array that we are sending the message to into the conversation as a JSON string. And then we set another parameter where we say that the output must be a JSON object. And we instruct the model to return a valid JSON string, which we then can parse again and return to the user. So this is some way how you can configure and restrict the format of the output results, not only by providing an instruction, but also by technically ensuring that we get back a valid JSON object to this configuration. Yep. Yes. What's also interesting to mention about this conversation editor here is that this is actually just some kind of DSL, some specific language which is parsed and generated whenever I change anything. And actually, part of this DSL is not only this writing of assistant, so I can actually add another assistant message here, which then is understood as an assistant message, or I could write system, and then it is understood as a system message. And part of this DSL, so this is not a string-based DSL, but actually a text-based DSL. So when I change the formatting of the text and do not have this as bold, then this is not understood as a new message. So in this case, the syntax does not only lie in this prefixes here, but actually in the formatting of the text. So the text must be bold, so for this to work. Yeah, just a small gimmick. Okay, then the next thing that we can do is build agents in a more elaborate way. So this building agents from the conversation editor is helpful for prototyping. So you can directly try out some possible setup with prompts and functions even before implementing them, and then directly connect them to your image. But if you want to build larger agents, we can also use a class-based approach for this. And for this, we can now try to create a small agent which actually can access with all the different parts of the Squeak image. And for this, we can just subclass from semantic agent here and create a new Squeak agent. And here we define 2 methods. First, we override initialize conversation. which we only do to provide a prompt. So we can say a conversation at system methods. You are an assistant that has access to this weak image of the user. And the second thing that we can do is to define a function that the agent can call. Let's call it eval. And for this, we define a pragma for a function, which is called eval and takes one argument, an expression, which should be a string. We can also provide an explanation for this, a Smalltalk expression or script. For example, this could be something like p plus 3, or it's a multi-line expression with x, which does something like an assignment and returns the object or whatever. Thus that we have a definition of this function. We also need a comment for the method, evaluates expression in the Smalltalk image, in the Squeak image. And then we can implement this by just saying compiler evaluate a string. Okay, I missed this character here. And just if I have not done anything wrong, it should be enough to start this agent. So we can say Squeak agent open new conversation and start with a simple question for the beginning, like what is 2 plus 3 again? And okay, in this case, it has not called the function. So I can force it to do so. And it also works in this case. And now we can do something more exciting, like how many open windows do I have? And then I'm curious how well this works this time. And you can already see that it runs multiple expressions because it makes some syntax errors. But in the end, it managed to do it. And I suppose that this is 16. Yes, it could work. Yes, and so it just, what has it done here? We can also inspect it. It says, okay, active was submove select assistant window. It's not the best approach to solve this problem, but it works. And it has tried out some other things before, which is also interesting to study how bad the understanding on GPT regarding Smalltalk is. So at the beginning, what had it done here? And here it missed some brackets about this expression here, and thus got a message not understood. And here it did the same error, and only in the fourth attempt it managed to correctly do this, actually not even by sending the size message, but by getting all the results and then counting it manually. So not very perfect, but it's a demonstration what is possible right now, and it also shows that it makes a lot of sense to use a specialized model which is capable of Smalltalk code better than GPT-4, but this is not something which we have tried out so far. Any questions so far?
So what caused it to retry then? So how did it, like when it got an error, what was the, in the method that you wrote, you could see it evaluating. So is there something that it's in your base class? Is it kind of catching the error and saying, okay, try again?
No, that's so we catch the error in the base class. This is the only thing. So we get this error here. But the model is trained by itself to, yes, retry on errors. So if you have ever used ChatGPT Plus, you can see something similar there as well. There it has access to a Python code, Python Jupyter notebook, and some things work there in a similar way. So it tries to run code, and if it fails, then it tries again a number of times before it ultimately either gets the correct result or says, I cannot solve this. So this is some kind of the pre-training of the model, which you do not need to do yourself.
Yeah. And what, there's some limit on how many times it retries before giving up? You've got some sort of...
Yeah, I think you can control this through the system message. So if I say you only have one attempt, or I could also manually remove the function later, or if I say give an instruction you only have one attempt, then it will very quickly press terminate. But for some agents, I explicitly did the other way and said, if they cannot solve the problem, we try many times. And in one situation, it actually led to the agent never stopping, but trying for several minutes and spending more and more dollars because I was not attentive and stopped it. And yeah.
So if you ask it to write a string method that capitalizes the first and last letters.
Okay, let's try this. This sounds good. Okay. Yeah, we can just, let's just here, write a string message that capitalizes first and last letter of the string. Should we instruct it to print out the result or to directly compile it into the string class to use it?
Oh, okay, yeah.
Okay, compile it directly into string. Let's see what it does. Okay, it seems I made a syntax error. Still a syntax error.
So
okay.
this is working with the GPT-4 model out of the box. I mean, without any fine tuning or anything.
Exactly, yes.
Wow.
And here's the message, and now we can say, try it with hello. Okay, seems to have worked.
That's awesome.
Yeah. For small examples, it works, but I can tell you from practice that it's sometimes when it sees a cascade, then it assumes that semicolons mean the end of a statement, and then it inserts them everywhere and cannot run any code anymore. So you can fix this a little bit by providing some Smalltalk examples in the context, which again makes every request a bit more expensive. Yes, you can also, what I actually have not yet tried or have tried to tried a little bit is that in the instruction describe the syntax in natural language, like a semicolon is part of a cascade, a dot ends a statement, and so on. But it's really harder than just using the model for any other language like Python, which it already understands very well.
Yeah, my initial system prompt before the conversation starts has gotten more and more elaborate as I keep fixing mistakes from previous conversations.
Yeah, I can imagine that. The prompt, which I will later show you the agent from my master thesis, and the prompt for that actually was, I think, 5 printed pages of paper long. And this was even without all the dynamic context that it would get later.
Yeah, wow.
That seems to be, a very important direction to take it in if you want to try and make an oracle. I'm very impressed by this technology. I just want to report something that happened last week in Buenos Aires. I was confronted by a bug in the FFI on macOS Apple Silicon that didn't manifest itself on any of the other platforms. And ChatGPT was able to synthesize 2 separate documents to get the correct answer, and this was about optional parameters being passed on the stack, which was not documented in the main Apple documentation on the FFI, but was a side comment in a completely different document on how to port x86-64 code to Apple Silicon. So it was really cool. But this right now is stateless apart from the prompt that you can give it the corrected conversation. So my question is kind of in 2 parts. How do you go about improving the learning so that this can become some kind of real oracle that has real knowledge about the Squeak system, and how can you combine different people's conversations so that one can develop a kind of a community rather than a single user model?
Well, what's traditionally done is either providing more context to the model or fine-tuning it. Self-learning agents, I think it's a different story. There's for sure some research about this, which I do not know too well. Well, in ChatGPT, you have this memory feature, so ChatGPT also can remember some basic things. But for one of the agents I created recently, I also noticed that in every conversation, I started to explain to it again how it could access the source code of a method or something like that. And yes, I think you could build some memory feature and ask the model to reflect from time to time and store its learning in a file and later looks the learnings up from there. I don't know how well this would scale, especially for multi-user, but yes, something like this would be more effective, I think, than just providing everything into the context, which still human persons need to assemble first. Yeah, so that's a good point.
I have a question.
Yeah.
In fact, two questions. First of all, what kind of information do you provide in every attempt? I mean, every time you retry with these evaluations, like for instance, let's suppose that in the previous example you get a message not understood, some exemption, and what kind of information about the exception, or probably if you have tested that, you provide to the LLM. And secondly, how do you make sure or try to force the LLM to, for instance, use the function calls? Because sometimes I notice that even when you give the thing like many functions, like for instance for evaluating or searching stuff, it is difficult to make it to use it unless you are super explicit about use this evaluation function, like you did before.
Mm-hmm. Yeah, for the first question, here when I have turned on the advanced mode, you see everything that the model uses, and so you can see that the only thing that it sees is actually this error message. So this is just, let's take a closer look at this, what we get here. This is just an error object which has the message of the string in it. So that is all. So there's not even a call stick included at the moment. But this information seems to be enough for it to, in most of the situations, not in all situations, be able to fix the code by itself. The second question was about forcing it to call a function. You can do this with some extra parameter. So I think I have an example of this somewhere. Yes, when you add a function or when you push a function, so that it's only used temporarily, you can specify a force away with any, so that it is forced to call any function or with a specific function name to call. And then the model infrastructure will ensure that actually a function call is made. Does this answer your question?
Yeah. I was thinking about, for instance, in a specific case of a message not understood, you can, for instance, provide it with the I don't know, the protocol the object actually understands, or even if you have given the thing a function to retrieve the protocol of a given class or a given object, can be used in front of a message not understood. But the point is that I found in my modest test of this thing really difficult to force it to do that. I mean, it hit some, for instance, it called this eval function that ended up in a message not understood, and then you have all the information in your system that the LLM can use to recover. You found that it recovers very well with a few information you provide back in the context, like, okay, I had this error, so the thing tries different stuff and then it recovers, and if I understood correctly. But I was wondering about the chances that the LLM use the tools you give it for recovering in other cases.
Yeah, well, what I think, what I told it and some agents to do was, when you see a message not understood, then please take a look at the interfaces that the class actually understands, so you can find out what you could send instead. Yes, I have.
Can you ask it how it determines what the interface of a class is?
How it does it? Okay. Let's find out what messages string understands. Something like that?
No, ask it how it determines the interface of a class. How do you determine the interface of a class?
Okay, so this gives me more some instruction how I could do it by myself. How can you do it? Yep. Do it and then tell me how you did. Okay.
Oh, I thought
yes.
you were going to actually make it do it and then look at the traffic.
Yeah, but after that it maybe is, yes, after that it also explains me how I did so.
Right. What I want to do is test. You know, is it capable of understanding inheritance, and is it capable of accumulating all of the methods up the instance side?
Yes, I could ask it for it, and it would probably do it.
The answer is yes. Yeah. It already knows about inheritance from its pre-training.
Okay. Yeah, it works also. Okay.
So now ask it what are the testing methods that string understands.
I was then going to ask it to write some tests for that capitalized first and last, just to, and then finally create a hangman game.
Yeah, it does not work too well. So I would usually provide it with some better instructions about things like how the categories in Smalltalk work. I think it might have some understanding of it, but like something which you have heard 20 years about, not very exact knowledge.
It would be different. It would be different if you said unit testing instead of just testing.
Unit. Well, I thought we talk about the testing category, or I understood earlier wrong.
Oh, sorry.
I'm not sure.
Or if you use the word protocol.
Find all methods on string in the testing protocol. Yeah, it seems to work. Okay. Great. Yes, I will continue because I noticed the time is evolving quicker than I had expected. Something else which I also have for you is semantic search. So the idea of embeddings, I mentioned the idea of embeddings to you before, and what is commonly done is just to store different documents from any information source in a database, which is and connect these entries to the embeddings, so you can do a search for us. This is also called a vector database. And we have a small vector database in Squeak. It's not efficient. It has a linear search time instead of something which is more like a constant search time, but it's fast enough for most operations. And something which we now can do is create a semantic search feature for different methods in the image. And for this, I create a small corpus. Corpus is our name for this vector database. And say it should have a title block and a content block. And in the title block of every method, we take its selector, and in the content block of every method, we take its source. And then we can add all methods from, let's say, our semantic text package. So we can say add all frag, add all frag, add, how was it called? I need to look this up again. Add fragment documents from all. Okay. And then we say semantic text package info methods. And then we can update the embeddings, and this will actually make a request to the embedding model of the API. This takes a few seconds. And once we are done with that, we can take a look at this corpus and see that we actually have the different documents for the different methods in this package available, and for each we have an embedding vector. And now we can use that for doing different kinds of search. So we can start with one base methods. Let's say we use this add function here, or add function action, and we can use this method reference and looks this up in the corpus and say, let's find the 20 most similar methods to that method. So find object 20 similar to object method. And then we get a list of the most similar methods to this starting point. So we find that add function args action looks very similar to add function action, which is actually true. And then we also find some constructors and some other methods. So this can be a helpful feature when you are exploring some code and maybe are searching for duplicates or for other codes that you might want to read next. And next to the similarity search, we can also do a semantic search with a query. And so I could do something like find objects 20 similar to query, change temperature. And when we run that, then we find some method that illustrate how we can change the temperature of our conversation. And if we now move one step further and combine this with our agent, we can build an agent like this here. So we just have a small agent here. You are an assistant that answers questions about the semantic text package. We give it a search documentation function, which creates such a semantic corpus. And runs this query with a given search term here, and the search term was AI generated in this case. And when we then call this and ask it, how can I change the temperature of a conversation? Then after a couple of seconds and spending a few cents, it's not yet optimized, so we create the corpus again here. And after a few seconds, we get back an answer, which actually just explains how I can do this by just using this code example, and it also explains what the temperature does. And so it has assembled information from different methods in the image here and used them to provide an answer to me. This is also called retrieval-augmented generation, and it's a helpful way to combine the strengths of language models for synthesizing and combining information and semantic search for retrieving information from a large unstructured data set. Any questions so far?
Yeah, so do you think there's any chance that you could make it read a corpus of code and actually write comments about what the code was meant to do, not what it actually does? This has long been one of my arguments with the whole process of software engineering, and it's kind of a fantasy. Somebody might one day fix it.
What would you like to do it with the code and find out what
I would like to be able to feed an AI type system a whole body of code and have it comment it, or not comment it as in this code does so and so, but work out what it is the dimwit that wrote it actually meant it to do.
Yeah,
because this is it's the crucial point of documentation and commentary, and nobody does it.
Yes, creating the why comments, not the what comments. Yeah,
and the stuff I didn't do, and it's impossible basically. But I don't know. You seem to be doing stuff that's close to miraculous, so maybe you can solve some of it.
I have not tried this, but I think to some degree it should be possible. Yes, I would mainly spend too much time and money if I tried it out right now. Yes, but I don't see why this should not work. You just need to provide as much information as possible from the image to the prompt, to the context, and prompt it to output the same code with meaningful comments. And actually what we also can do here is we can choose a different model. And for O is pretty good, but if we would choose the O1 model, this also does some internal thinking and reasoning before answering. And so I expect that with this model, I think it should be possible.
Yeah, I mean, being slightly more serious than snarky, I guess if you actually set it up so that it didn't just read the code, but actually could read all the design documents that I hope people actually create and the emails of all the people on the team relevant to the subject, you might actually be able to get somewhere.
Yeah. Maybe I will try this out later and write on the list when I have success.
How well does it do to just comment a particular, like just a method? I mean, it's not exactly what Tim's asking, but I'm curious now. You got me thinking. It's like if you took like some longish method and said, how would you comment this if you were a maintainer or something?
Okay, I think one example of this, just because I have used this before for testing, this method is pretty complicated. So we can remove the comment and try to have it add one. Actually, we have even a convenient feature for this. I just can select the code and then say, ask question about it, and then say, add a meaningful comment to the top of this message. Well, let's see what it does. It's a bit lengthy, I think, but it looks...
It's kind of like what I'm asking for, though. It's not just, it tells you exactly, it's trying to discern the intent, isn't it?
That's actually pretty good.
Yeah.
Yeah, I mean, it's kind of a similar job to doing a précis of a piece of prose.
Yeah. Wow.
We could also feed it with some other examples of good comments. So maybe something like that. Here are other examples that make perfect Smalltalk comments. Oops, now the bold text becomes a problem because it looks like another role in the conversation. Also select, so this should be enough, I think. So now let's try it again. Okay, this looks more like a Smalltalk comment, doesn't it? In the first line, we see what it does, and in the last line, the return value. Yep, seems to work.
Amazing.
Okay, I try to speed it.
Teach it to replace the returns in the two blocks with a return of the expression, and to replace equals nil if true, if false, with if nil, if not nil. Go back to the Pitchback method. Go back the last statement of the Pitchback method. See if you can use it to lint it.
Okay.
Right. So the last phrase in that method, the very last phrase. Look at the very last phrase. Right. I would pull the return out so that it says, return desmap, but instead of equals nil if true, if false, I would use if nil, if not nil. So can you teach it that? Teach it correct.
It messed up with the formatting a bit, but
Yeah,
I think
that's pretty good. That's pretty good. Now teach it to move the returns out.
okay, seems to work.
Wow.
Yeah, that's pretty good.
Oh my God, that is even just like say move the returns out.
It was so terse. That's pretty good.
Yeah.
Yeah, I mean, this is
we're all old enough to retire.
But are you
Now-
actually?
But hang on, Christoph. Can you ask it? Can you ask it meta questions like why is that a good idea? Or why
You
would
sure
that
can.
be a good or bad idea?
Oh yeah.
Could you repeat? Like that or something else?
Yeah.
Yeah. Well, this is actually something. This is something which GPTs are good at. So they have seen tons of refactoring guides and refactoring examples. And yes, for teaching basics about programming languages, I think this already works pretty well.
I have a question here. Are you actually teaching it, or is it just remembering all these things, this like move, combine, how you say, use if nil, if not nil, rather than checking for equality of nil. So it's only in this context. So if you start another conversation with ChatGPT, won't.
If I start another conversation, it knows as little as the beginning of this conversation. Yeah.
But yeah, if you were to say something like rewrite the method to be as clear as possible, it would start drawing upon optimizations like that.
Yeah.
So you need to hold on to the context somehow if you want to remember all the teachings that you've done.
Well,
yeah, a lot of them would probably end up in the system prompts in future conversations before the conversation begins.
Yeah.
Okay.
You could build some mechanism for storing these instructions. I have not done this so far, but should not be too complicated.
Christoph, Peter here. I'm curious, how much effort, first of all, I love what you're doing here. How much effort would it take to migrate this over to Pharo?
I don't know how many interfaces Pharo does not support. So the first thing is a dependency on the web client package for accessing the API. Thus, this is extracted in a few methods. I have not used Pharo for a lot of things, but yes, there is some web interface which you need to change. And for the UI part, I use a tool builder framework. I don't know, and a bit of Morphic dependencies. I don't know what of that is available in Pharo. Would need to check out.
Thank you.
Yeah, but I think there's also some Pharo-specific OpenAI client. I don't know how far it goes with regard to function calling or UI integration, but there was some package for that. Okay, if there are no further questions, then I will try to. I think we already have spent half of the available time, and I have so much more to show you. So we have some different integrations into the tool. You already have seen that in the context menu of any editor. We have some functions such as summarizing, explaining something, and so on. So for instance, we could also, for whatever reason, we could also ask it to read out this comment.
Average the pixels in ArrayPix to produce a destination pixel.
Okay, whenever you should need that, it's possible. And you can also, well, I cannot because my microphone is currently used for Zoom, but in theory, I could also dictate in my comments here. Yeah, but this won't work right now. Yes, and we also can use this for some more meaningful things, such as having a very long class comment in this method, which would take me, I think, half an hour to read and understand. Or I can say, summarize it, and then the LLM does the work for me and presents me with a still pretty long, but much more concise summary of what this class actually does. Yep. This was about integration into the system browser. Then something else which we also did was integrating this into the help browser. For this, so don't know the help browser, this just contains some documentation materials about Squeak. It's also extensible by different packages, so SemanticText has its own entry. And 1 year ago, I also wrote a small LaTeX parser to parse the entire Squeak by example book, so we can also read this in the image, including all images and so on, all screenshots. And so this is some kind of interesting data source for accessing different information in the system. And for this, we can also use AI support. So we now can ask a question like how, or just cast into string. And normally, this does not give me any results because there is no help topic which contains the term cast because it's not really a Smalltalk term. But we can now enable in the settings semantic search in help browsers. And if I then search for this term again, then it does a semantic search by creating a semantic corpus of all the help articles and selects some relevant articles and also provides me with an automated semantic smart reply of the different topics it found. So we can also use this as some retrieval-augmented generation tool for accessing the help. In a similar style, I need to switch to another image because I have not yet committed that. I hope this works. Okay, we can also have you can also see some recommendations of related topics, which is just a similarity charts. So when I am reading any article in the help, such as about how to contribute to Squeak, and then there is some description how you can do your first contribution, and then just beyond that, below that, we see some recommendations of articles that, for instance, describe the different versioning tools that you could use for that, or the community model and something else. So also helpful in some situations. Okay, the third integration, which we have built, is for Squeak Inbox Talk. Squeak Inbox Talk is a client for the mailing list for Squeak Dev, which I have built a couple of years ago with Marcel. And the idea here is just that we can combine all the mailing lists from over 20 years of Squeak history together with all the patches and versions from Monticello, from the version control system, and access them in a single tool. And this is contains more than, I think, 200,000 messages in total. So this is kind of a data treasure with a lot of interesting information. And so I also try to use AI for this. And the first thing which we have got here is, again, a similar conversations feature. And this, well, in this example, I think it looks more interesting. It's a bit limited right now in this image, because in this image, I only have downloaded the last year of the mailing list, but I actually had a couple of situations where I had asked about something like how can you store all floats of an array efficiently in a file. And after sending that messages, I built that feature and found a conversation that was 15 years old, contained the same question and also contained an answer. So this can actually be helpful in some situations. Another thing is the smart summary feature, which gives me a short AI-generated summary of long discussions, and this can be especially helpful when you want to come up with anything that was discussed on the mailing list recently. So we even have the structure here, which is intended for maintainers, so that I can directly see as the bottom action items, okay, we need to discuss this, we need to merge this, or anything else, and can be helpful for lengthy discussions. And based on that, I can also ask further questions, such as what was Henry's argument. And yeah, in some situations, it is actually more helpful than reading all the entire original conversation, which can become pretty long. Finally, we also have another AI agent here for chatting with the entire mailing list. And one thing that we can do with that is ask it to summarize the recent activity on the mailing list from last week. And then we actually combine multiple. Okay, this only works in my other image because I haven't yet committed all of that. Summarize the recent activity on the list from the last week. Okay, this is still loading here. But this actually uses a combination of multiple requests to large language models, because even all the conversations from multiple weeks can be too long to fit into the context window of the model. And so instead we collect it into different chunks, summarize each chunk separately, and then ask the main assistant here to summarize the result of that. And so this takes a little bit longer. And after that, we get some structured high-level overview of the different conversations on the list, also with pointers to particular individual conversations. And while this does not work perfect and sometimes ignores important things, it's still a helpful way to understand what have been going on the mailing list. And some other feature, which I also actually could have used and could successfully use in practice is asking specific questions about the mailing list. One example is that Marcel, a couple of years, mentioned that we should try to get ephemerons into the trunk. And at this point, I had no idea what ephemerons are. And so I could now just talk to my agent and ask it, what are ephemerons and what is the current state of integrating them into the trunk. And then the agent will start by doing some searches on the mailing list, which includes both, okay, in this case, it also gets the recent conversations, which does not make sense. But anyway, it searches the mailing list by using different strategies, such as a string-based search and a semantic search. Unfortunately, it takes a bit longer because it also gets the recent conversations, which we would not have needed for the task. Let's see what it does.
And is this using your pluggable vector database that you talked about earlier? Is that?
Yes, exactly. I have completed embeddings for the entire mailing list for this purpose. And in the end, we here actually get a pretty helpful summary where we get an explanation of what ephemerons are, because Elliot has and others have described this.
Yeah, but it's wrong. It hasn't got the essence of it at all, which is interesting. But that's fair enough.
Oh, what a pity. Yeah. So what that's the theoretical approach.
But this is the real question, right? Because we're at this inflection point. I mean, between syntax and semantics, and it's a really important thing is to what degree syntax scales towards semantics. And I'm itching to sit with it and try and teach it some real semantics in a domain in which I'm an expert, and see if it can come up with stuff, because what it appears to be able to do in terms of especially the synthesizing of information across different domains, the image and the mailing list and past commits is really powerful. I've seen it be able to connect information in a really powerful way, even if it doesn't really grasp the underlying semantics. Yeah. But can it? To what degree can it be taught semantics? And so the part of the issue here is what have you thought about what it would take to build your own ChatGPT on the corpus and escape the restrictions of the financial interface and also this thing of the stateless interface.
Well, if they want to train their own ChatGPT, I think they
no, not train your own, and build your own ChatGPT. Not just train one, but build your own.
Well, what is ChatGPT? ChatGPT is first a language model, second a short context, and third a nice UI. And we already have a UI. Not sure how nice it is, but we have one, and we have an existing model. So the last part would be to create some better prompt, but that's for the extent of all the different information that you can know about Squeak, which is a couple of books and yes, hundreds of thousands of lists on the mailing list, of mails on the mailing list. This is too long to fit into the context. So I think the most viable way, if they actually want a ChatGPT that works really well for Squeak, would be yes, training or fine-tuning your own model.
So what's the finance of that? If the community was to try and build something that was open only to the community, what do you know roughly what that kind of thing costs?
It's hard to say. So it's OpenAI makes it possible to fine-tune the models, which you can use to maybe train it to answer in a certain style, to call functions in certain patterns and things like that. But I don't think, I'm not too familiar with it, but I don't think you can actually use it to teach it a large amount of information, because fine-tuning is more for having an understanding of patterns and not for exact knowledge. So I think you need to do much more training when you actually want the model to learn things. And I don't even know whether we have enough redundancy of data for that. I'm not familiar with it, but I think for ChatGPT, they have used thousands of books about Python, and we only have a few about Squeak. And as from the financial point, I don't know. OpenAI is doing collaborations with many companies for doing such kinds of tasks, but it's likely that this, I don't know. I cannot imagine the number, but I think it's really more than a small community could afford to donate. Yeah.
Maybe one of the open source language models would be a better starting point.
Yeah, but you also need very powerful hardware to run it and to train it. So everything that you can run on your own machine is probably not smart enough, I would say, for engaging in conversations.
But could you federate, I mean, my M1 Silicon, Apple Silicon laptop is extremely powerful, and there are lots of people in the community have them. So we could probably lay our hands on like 100, 200 of these things, and the new one is 4 times faster, etc. So with the right kind of distributed programming framework, you might be able to, federate.
Perhaps this is
it might be good enough, but in general, use cases are prompting companies to consider nuclear power to come up with enough energy for doing this training.
Yeah, but Craig, that's in really big domains. The Smalltalk domain is relatively small, right?
Yeah, like I said, it might be small enough. Probably is. It probably is. Yeah.
NVIDIA makes some Mac Mini type, old Mac Mini type size machines that are $1,000, $2,000, $3,000 that are appear to have pretty impressive performance for this kind of thing. So it's not a budget that's beyond possibility.
My understanding is that the existing model, they've been trained with a lot of code from Python and the mainstream languages, but they already know, or they have some knowledge how to program, and they can do some write some Smalltalk code. If we want to have it write better Smalltalk code, then we have to take some of those models and use fine tuning, which is you add your own repository of a Smalltalk, or as much Smalltalk code as you want, or even you have to split it by flavor. So one for Squeak, one for Faro, one for Visual Age, whatever, and then you will be you have fine-tuned your model with that Smalltalk flavor. So it will be able to write better Squeak code, better Faro code, better Visual Age code. That's
but why start from Faro when you've got from Python when you've got test suites and images that go back to the mid-70s, and
because that's very expensive and it takes a lot of time, so then you add it.
I think
the question is not how much, the question is are you going to get something qualitatively better? I mean, if you start from Python, I would think that you would get something qualitatively worse, because Smalltalk has a fundamentally better implementation of object orientation than Python. So,
there's already a hell of a lot of Smalltalk knowledge in the pre-training for many of the large language models, certainly the OpenAI one. I'm on the fine-tuning team. I think there's already enough quality knowledge about Smalltalk in the pre-training of this model that you can fine-tune your way toward good enough. And indeed, in keeping with the system we're talking about, Smalltalk being a dynamic system, a lot of what you would want the thing to know has to be taught on the fly. It's not something that can be pre-trained inherently.
I think the question is also about what is Smalltalk. So Smalltalk, the syntax, no problem. And detailed understanding of every concept in the image, so the model is confident in working with it and even changing it, is, I think, much harder, because there is also not enough reflection available, not enough documentation or books available, or certain concepts that are implemented in the image.
Yeah, Smalltalk is a living, changing, interacting set of contracts of message interfaces. No matter how much pre-training you gave it about a specific snapshot of a particular Smalltalk system, you'd still want it to learn a bunch of things about code that got written in the meantime.
Mm-hmm.
Yeah,
I
but,
think,
I think what
semantics,
Christoph has shown us is a lot of the way toward that.
But Craig, the semantics of the language hasn't changed since the 80s. The binding semantics. There's some small detailed changes to things like closes, etc.
Oh, indeed, and that knowledge is already in the pre-training for this model.
Right, and meaning emerges from the source text. So whether you call that fine tuning or you call it training, the interesting thing to me is having the thing so trained and finding out to what degree you can push on its notion of semantics. Right. I mean, there's a slippery slope here, right? Because Christoph, you said, raising its temperature changes its creativity. Arguably, that's not what's happening at all. It's just relaxing some constraints, and what makes an agent or a human being creative, is an interesting thing. Certainly in music. The degree to which you absorb theory and absorb physical abilities with the instrument, and absorb the ability to listen, etc. So there are many specific skills that lead into creativity, and removing constraints from the ability with which you can listen, understand theory, and manipulate your instrument doesn't lead to more creativity. It leads to sloppy playing and incommunicative people who are not participating. So there's a really interesting kind of set of philosophical questions here that you're raising.
Yeah, I'd want to model meta qualities of the system, like boredom.
So being conscious of the time, and so in 10 minutes we have Gishe going to start presenting about the website. Shall we leave Christoph to close? Continue a bit with the presentation and see. There are questions about where to get the image and so on, or where to get your project, basically.
How much time do I still have? I thought it was until 3/4. Okay, so I still.
We are flexible. Gishe, I don't know if you are on a hurry or.
No, it's okay. It's okay. It's okay.
Yeah.
It's okay.
Perfect. Thank you.
So if you'd like, I can show you one other prototype we built. If time is not so much, then I will just end the talk now, whatever you prefer.
I think show the extra project. I think you'd be given a bit of leeway to finish your thought process.
Yeah, so the final thing, yes. What we also built is an exploratory programming agent so that you can actually talk to objects in natural language, which in a nutshell means that we have an agent that sits between the programmer and the different objects in the system, and it allows you to ask natural language questions. So instead of showing you the slides, I will just show you an example. So we have something like a small order object, which could be from some kind of object, from some kind of shopping system, and you might be debugging something or so on, and you find out some order for this, and want to have a simple question about this, such as when was this order created? And traditionally, we still need to do a lot of manual experiments for this, exploring the different properties of the object, eventually finding something, but still we need to somehow convert it by writing a print it and this is not even correct because it is a millisecond timestamp, so I need to convert it first. And so this can take a lot of a lot of mental overhead. And instead, we have integrated a conversation mode right into the inspector here. So I can ask, when was this order created? And then the exploratory programming agent starts to research this object interface by itself, tries out some different statements, and iterates as long as required to answer this question, and finally comes up with a correct answer. And I'm actually surprised that it works in the first attempt this time. Often I had to ask it a second time to convert the integer into a date. And internally, you can see that we here have browsed the package of this implementation, browsed the senders of some method, browsed some classes, and created and ran some expressions until we got the correct result. So this is, yes, more generally an approach to further streamline the interaction with objects and the exploration of objects, so we can, yes, literally talk to objects in natural language without needing too many single tools. Yes, we've got some other examples of that, which I don't want to detail for now. But something which is also interesting is that, for instance, we can have a watch morph, this beautiful morph here, and then from the inspector, we can, for instance, ask it, how many children do you have? And then the assistant researches the interface again, gives me the correct answer, and then I can also not only ask questions about this object, but also instruct the object to change itself. So I can, for instance, say, make all digits red, and let's see whether that works. It has worked, okay. And in the similar fashion, I could say, rotate them all. And yes, so this is also some approach which you can use for like prototyping UIs or any other kind of dynamic interaction with objects. In this case, it is having more problems because it is hallucinating a method. But yes, more or less, this is also something which you can do. And finally, we also integrated this not only into inspectors, but also, for instance, in the debugger or also in the language itself. So you could also say, self make all digits red, just write this regular Smalltalk code. And then the agent is invocated right from the code and is also able to return another Smalltalk object, even though we do not need this in this example. And let's see whether this works today or not. Okay, it was already wet, so we cannot see the difference. But yes, so we can also use exploratory programming agent, insert an inspector, also in other tools like the debugger, or even as part of the Smalltalk language itself. Yes, we have used this for different approaches and have studied how this changes the programming experience if you use fewer traditional tools, but whether rely on using natural language interactions for different things, which has some advantages, such as in streamlining your process, but you also miss some important things, such as manually going through a method when you are searching for something, and by the way, learning something else about the system. So it has its pros and it has also its cons. But in general, yes, my vision would be that maybe in a few years from now, such tools, evolve further, the models become more powerful and understand the languages better. And the IDEs of the future, particularly the debuggers of the future, would have this as some kind of a standard feature.
So for when you ask it when the order was created, is it understands that when is like something to do with date time, so it's looking for something that has something time based, and then is it like using inspection to just like go through the object fields, find something that looks like that, and then, or is it looking at the code and figuring out that there is a method that does that, or all of these things?
Yes, we provided in this case actually with a longer context, which describes in detail what it should do. I can turn it on, and then you can see the length of the slider to get an impression. So we have different tools for accessing the objects to evaluate code, browse classes, and so on. We have a long prompt, and we also provided with a few initial function calls. And what we do here is, amongst others, to request all the instance variables of the object. So we see that there is an ID and there is a properties object. And this is what the agent gets when it is invoked. And then it, in this case, has started by browsing some of the code. And okay, it's too much to process this all now. But in the end, it browses the different classes. It also takes a look at the implementation, which is helpful for understanding how this properties object is constructed. But in other situations, it also might just run a lot of expressions to retrieve the different variables and then to go further to retrieve their variables and so on.
Wow. So in fact, and partly having these tools to see what it's doing as well is super important. That's cool.
Yeah, it's required a bit more instructions to teach it to use these tools, because it turns out that GPT, I mean, it's able to run code and to correct itself, but it just does not have the level of curiosity that you need to be a good small talker. It does not by default take a look at all variables and try to understand as much as possible about an object, but it just is very, very lazy. So we really provided with a lot of text that says, you should try out different things. If something does not work, you should try out at least 3 alternatives. And then when we have luck, it tries out 2 of them. And yeah, so that's not the nature of GPT, but with some instructions and examples, you can achieve that to some degree. Yeah, also, what I also was able to do with that is create something like statistics and simple diagrams of the mailing list. Sometimes it works, sometimes it fails, and when it fails, then it stumbles up on simple syntax errors also on. But yes, I think there's a lot of potential.
Wow. God, we could talk for weeks on all of this stuff. It's amazing. Jeez.
It's pretty cool. I only wring my hands over how much energy and water this is using.
Yes.
I had done some estimation of that. It's no longer up to date because the models use more caching today. But I think 1 year ago or 2 years ago, it might have been possible that if they would use the agent continuously for 1 hour, you might spend, I think, 60 liters of water.
Yeah. Yeah, gives me the willies.
Yeah. Yes, we also integrated this in a debugger where it does not work too well, but if they have a complex call stack with a lot of information and want to know a single thing like this fail block here, and we want to do what it does, where it comes from, we can also use the chat here and ask, where is fail block from and what exactly does it do? I'm already screaming this because it's often too lazy to answer this question in the right way. And then it accesses the information from the call stack. And if we are lucky, then we get an answer which makes sense. Yes, it says that it is defined in this method. Okay, yeah, but you can see that it says somewhere potentially, because in this case it was too lazy to actually look at the source code of all the methods, and so it did not come up with the correct answer. But in theory, it could also be helpful. Actually, something else which I can show you very briefly is that we can also use this for, oops. We can also use this when we are in a trace debugger, which is a back-in-time debugger I have described on the mailing list earlier, that we are able to talk to the history of objects. So if this works right now, we could Okay, here we are inside of this office. So I have just traced a program here which parses a regular expression using the trace debugger. And also here I have got the chat interface, and now I can ask questions such as what is look ahead now? And then we get back an obvious answer where look ahead is currently nil. And then I can ask it, what will it be in the future? And okay, this is not the answer I wanted. What is it? History, maybe this works better. And then we also see a summary of how this value has changed over the course of time. And so we cannot even talk to objects in natural language, but we can even talk to the to the history or to the future of objects in a program trace. And I could even ask it, for instance, where did it change to the closing, to the first closing bracket? And then it will give me the method which is relevant for that, which is, okay, inside parsing a piece from the regex parser. And so we can, yes, also use it to talk to the history of objects and their changes in a program execution.
Really nice.
Okay, yeah. If there was no second talk, I would show you more demos, but I don't want to disturb the second talk. So that's all for now, I think. I will also announce one other idea on the mailing list in the future very soon. And yes, I hope you liked it. If you want to try this out, so the obvious slide for the end, SemanticText is available on GitHub, and the Exploratory programming agent is available in a separate repository. Installation instructions are available in the repos. It works in Squeak, in the Squeak trunk, Squeak 6.1 alpha. And SemanticText also basically works in the last release of Squeak, Squeak 6.0. And yeah, if you want to read more about this, I have also described something on the mailing list, and we have published a paper about this. Here's also a generative AI-generated transcript of the talk I gave at the Onward conference, and part of this also is covered in my master's thesis. Yeah.
How was it received at Onward?
I think pretty well. I think there were not too many people available. I only joined the conference remotely. Maybe Marcel could tell more about this because he was there in person. Or maybe not. Yeah. Yes, but I have also talked to some people on Reddit, and other people wanted to see a demo. So I think, yes, some people understood what we were trying to do.
Yeah.
Yeah. Thank you a lot for being there. If there are further questions or also ideas for what we should build next, feel free to send me a message. Yes, and if you want to use it by yourself and need some help, I'll be happy to assist you.